Good morning friends, welcome back to online class. I am Subhashini Mudalia. Today we are going to study about the new topic, that is S block elements. So in the periodic table there is 4 blocks, S, P, D and F blocks are there. So the first and the second group is of S block elements. So see here in the group 1A, it's a lithium, sodium, potassium, rubidium, cesium and francium. In the group 2, it's a beryllium, magnesium, calcium, strontium, barium and radium. So group 1A is the alkali metals and group 2 is a alkaline earth metals. So the name, it's a alkali alkali metal is given by, because for example lithium oxide, sodium oxide, then it's a acidic oxide or a basic oxide. Yes, it's a basic oxides. That's why the name is given alkali metals. In this chapter, we are going to study about the characteristics, properties of S block elements, variation in properties of S block elements, variation in properties of S block compounds, uses of compounds of the S block elements. So the characteristic property means what? About the metallic character. Group 1 is having a high metallic character because of the all metal elements having a low electronegativity. Low electronegativity means what? It's having a tendency of donating the electrons. That's why it's a Li plus, Na plus. So it's a electropositive. So that's why it's a low electronegativity, having a low electronegativity. It's a basic oxides and hydroxides like NaO, NaOH. So it's a basic oxides and hydroxides. Ionic bond with a fixed oxidation state. All group 1 is having a oxidation state Na plus 1 balancing, and in the group 2 it having a +2 oxidation state. Characteristics, flame color, so they are having a different flame colors like lilac, brick red, yellow. Next, weak tendency to form a complex. It forms a compound. It is having a weak tendency to form a complex. See here the metallic character, the high tendency to lose electron to form a positive. See here, it is the loss of electron. What is the loss of electron? For example, sodium is Na281. So in the third orbit, one electron donates. So it have high tendency to the donate electron and gets a electropositive. Metallic character increases down both groups. Of course, as it go down, the metallic character increases. So in this, we are going to study about the metallic character, atomic radii, ionic radii. Next one is the electronegativity. It has a low nuclear attraction for outer electrons. It's highly electropositive, as you can see, Li plus, Na plus, K plus, rubidium, Rb plus, Cs plus, francium plus. So it has a high electropositive, so it's a low or a small electronegative. Negativity. Next, basic oxides. It forms a basic oxides like Li2O, Na2O, Na2O2, peroxide, superoxides, K2O2, KO2, Rb2O2. So we can name them also. Hydroxides like LiOH, NaOH, potassium hydroxide, rubidium hydroxides, cesium hydroxide, CSOH, like this, right? So it forms a basic oxides. Means what? What is the meaning of basic oxides? When you do a test of the litmus paper, red litmus turns to blue. That means it's a basic oxides. Same with the hydroxides. Now, the difference between the oxides, peroxides and superoxides. When reacts with the water in the oxide, O2 minus plus H2O, it gives 2OH minus. Hydroxide ion. What is 2OH minus? It's a hydroxide ion. So the peroxide, O2 2 minus. This needs to be very clear. What is oxide? Oxide means O minus 2. What is peroxide? O2 minus 2. And superoxide means 2O minus, or we can say O2 minus. O2 minus, that is a superoxide. So when this oxide reacts with the water H2O, it gives 2OH minus. O2 2 minus plus 2H2O, it gives H2O2. This is hydrogen peroxide plus 2OH minus. In the superoxide, 2O2 minus plus 2H2O, it gives 2OH minus plus H2O2 plus O2. Oxygen is released, hydrogen peroxide is in form of liquid, and hydroxide is also in the ion form. So this is a dot structure of a peroxide ion, superoxide ion. Lithium does not form peroxide or superoxide. That is LiO2. Li2O2 gives Li2O plus half O2. So it does not form peroxide or superoxide. Now about the hydroxides. As you go down, the hydroxides all are soluble and basic strength is increases. So it is a completely basic oxides. In group 2, as you go down, the solubility increases from the amphoteric to the basic. What is the meaning of amphoteric? Amphoteric means that the element reacts with both acidic as well as basic. That means it's a amphoteric. Base strength increases. Base strength increases. Means more basicity is there. Predominantly ionic with fixed oxidation state. Group 1 is what? Most electronegativity metals. It has a low first ionization enthalpy and extremely high second ionization energy. You can say ionization energy, ionization enthalpy, right? Form predominantly ionic compound with a non-metal by losing one electron, and it has a fixed oxidation state is +1. And in the group 2, electropositive metals are there. So it is having most electropositive metals have low first ionization energy as well as second ionization energy, but very high in the third ionization energy. Now what is ionization energy? It depends on the atomic radius. As the atomic radius increasing, ionization energy is decreasing. It's a vice versa. Okay, we'll show in the next slide. So here, having a fixed oxidation state, that is +2, beryllium and magnesium compound possess some degree of covalent character. Covalent character means what? Sharing of the electrons. Now, characteristics of the flame colors. Sodium chloride, Na plus Cl minus gives Na plus chlorine. So Na in the gaseous forms gives this one. So this is the electronic configuration. Neon 3s1, neon 3p1. So star means what? The configuration changes over here from 3s1 to 3p1. Flame colors will show you here. Lithium, the color of the lithium, when the lithium metal, you show this one is a Bunsen burner, this one is a loop which is having a platinum wire. So how to do a test? We have to make a loop, take a sample from here and then show in the Bunsen burner. You can see the different colors. If it shows a deep red color, it's a lithium. If it shows, if you are having a sample of sodium, like sodium chloride, sodium hydroxide in a solid form, and you are taking this platinum wire and keeping it in the flame for the flame test in the Bunsen burner, you can see yellow color. So if it shows yellow color, it's a sodium. Lilac. Lilac means what? It's a purple color, like brinjal color, right? So it's a potassium. Bluish red color, then it's a rubidium. And if it's a blue color, then it's a cesium. It should be kept in the outer layer where it shows the yellow one, not the inner or in the middle. Then only the clear flame we can see. In this group 2, calcium, then it's a brick red color. Strontium is a blood red color, bloody red color. Then it's a barium, it's an apple green color. This is the flame test. Now, variation in the properties of the elements. So there are the variations like atomic radii. As you go down in the group, the atomic radius increases as you go down because the number of the atomic number is increases. So atomic size also increases. So atomic radius also increases. And what about the ionogen enthalpy? As the atomic radius increases as you go down, the ionogen enthalpy decreases. Hydrogen enthalpy's melting point also increases. Reaction with the oxygen, water, hydrogen and chlorine will be studied next here. Now, so see here the trends in the atomic radius. See here, you can see sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So the atomic radius is decreasing, and ionic radius also here decreasing as you go from left to right, not from top to bottom. This is the period one. So in the period it is decreasing, and in the group it is increasing. The size is increasing. Okay. See here, this is the atomic radius. As you go down, the atomic size, atomic number, atomic radius is increasing as you go down the group. And as you go from left to right, that is across the period, the atomic size is decreasing. Okay, this is about the atomic radius. Now about the ionic radius. Obviously, the ionic atomic radius is increasing as you go down, then ionic radius also increasing, right? So as you go down the group size, ionic size is increasing. Okay. See here, clearly it is given the group 1 atomic radius as it is increasing, ionic radius also increasing. Same over here in the group 2. As you go down, the atomic radius as well as the ionic radius is increasing, and it is measured in the nanometer. About the ionogen enthalpy. Now, ionogen enthalpy, as you go down, the ionogen enthalpy decreases. Okay, it's a vice versa. So ionogen energy is the quality defined as the amount of energy required to remove the most loosely bound electron. The valence electron of an isolated gaseous atom to form a cation. For example, ionogen enthalpy is less in the sodium and it is more in the magnesium. As you go across the period, atomic size decreases. That's why ionogen energy is increasing. So we can write here as atomic size increases, ionogen enthalpy decreases. Okay. So just remember this one. As atomic size increases, ionogen enthalpy decreases. Atomic size and then atomic radius, ionogen, ion, atomic ions all are increases, and ionogen enthalpy decreases or ionogen energy decreases. See here the same, as you go across the period, ionogen enthalpy increases because the atomic size is decreased. Now about the hydration energy. With the sodium Na plus and water interaction, what will come? Na plus water. Obviously, it's a basic of hydroxide, so it's a NaOH. So see here, Na plus water gives M plus in aqueous form. The hydration enthalpy is the amount of energy released when 1 mole of aqueous ion is formed to form a gaseous ion. So see here, this is the Na plus ion, and here the water is there, HOH. See here water. So how it attracts? This is a plus, and this is in the form of polar negative. So both attracts to form a hydration. This process is called hydration. So the hydration reaction is a chemical reaction in which substance combines with water and it forms a compound. And this process is known as a hydration. And this is always in the form of a negative value. See here, Na plus water This is a hydrated sodium ion. So hydration energy is inversely proportional to the size of cation. So as the size of cation increases, hydration energy decreases. This you need to remember, the hydration energy. As the hydration energy increases, size of cation is decreases. Now about the oxidation and the reducing agent. So you know very well the oxidation state is +1 in the alkali metals and +2 in the alkaline earth metals like Na plus and Mg plus 2. So reducing agent, it's an excellent reducing agent, and here it's a weaker reducing agent as compared to the alkali metals. So we can write sodium is less reactive than potassium, then rubidium, cesium and lithium, as it is a reducing agent. Now about the melting and the boiling point. As you go down the group, the melting point decreases. And what about here in the group 2? As you, group 2 elements have higher melting and the boiling point compared to the group 1 elements. So here are the sequence of the melting point, as beryllium is a more having a more, or we can say high melting point than the calcium, then strontium, then barium and magnesium. This you need to remember, melting point and boiling point is as it is increases, the atomic size decreases, or we can say atomic size increases, boiling point and the melting point is decreases. Okay. About the density. In the alkali metals, density means what? Weight. So the alkali metals is low density, and in the alkaline earth metal it's a are denser than the alkali metals. So as you go down the group, the atomic mass increases, which more than the compensate the bigger atomic size. So therefore the density is increasing. Now about the flame coloration, we have studied right now as lithium, crimson red, sodium, golden yellow, potassium is lilac or pale violet, rubidium is purple and cesium is blue color. Flame coloration, we have done that also. Beryllium and magnesium, because of their high energy, however, do not impart any characteristics color to the Bunsen burner. So these property generally shows only in the S block elements, D block elements, not this in the flame coloration property. So in the calcium it is a brick red color, strontium is a crimson red, barium apple green, and radium is a crimson color. Hope you understood the topic very well. Thank you.